Greetings from the IAS Residential Education Center. I'm Jason, and today I'll be reviewing the codes and calculations used for determining the minimum required general lighting circuits in either a single-family or multifamily home. This is determined by using the general lighting calculation, one of a few branch circuit calculations used by electricians. The first step is to determine the square footage of the total living area as defined in Article 220.11 of your 2020 NEC. It states that for dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. So in most plan sets, you'll see many square footages listed for many different trades. The ones that we are looking for normally are listed under total living area. Next, I will multiply that square footage by the minimum unit load per square foot. The minimum unit load per foot for a single or multifamily dwelling is found in Article 220.14J in the NEC, and it states that for 1 and 2 family and multifamily dwellings, the minimum unit load shall not be less than 3 volt amps per square foot. After multiplying these together, you've calculated the total minimum lighting load for the home. This calculated minimum lighting load is used for other various calculations such as services. This value is expressed in volt amps. At this time, if you're not familiar with Ohm's law calculations, I suggest you take a moment and watch our tutorial videos on Ohm's law. The next step of the general lighting calculation is to determine the amperage being used for the general lighting circuits. The two most common amperage ratings for these circuits are 15 or 20 amp. Either of these amps is then multiplied by the voltage of the circuit, which is 120 volts. The product of these calculations is that for a 15 amp circuit, we would apply 1800 volt amps, and for a 20 amp circuit, we would apply 2400 volt amps. These volt amps represent the maximum volt amps per circuit. Finally, I will divide the minimum lighting load by the maximum volt amps per circuit. This total is the minimum required general lighting circuits required for this home. Any decimal value or fraction of a whole number must be rounded up to the next whole number. Since this calculation determines the minimum number of general lighting circuits, anything less than the quotient would not meet the minimum requirements. Also, we cannot install a partial circuit, so the only option is to increase the number of circuits to the next whole number. At this time, let's work an example problem out. You see here we have a 2,150 square foot home with a 150 square foot garage and a 100 square foot patio. We will exclude the garage and patio because they are not considered a living space area, and we will use the 2,150 square foot for our formula. We would then next multiply that by our 3 volt amps, and that would give us a total of 6,450 volt amps. For this first example, we are going to apply 15 amp general lighting circuits to this home. So we would then divide that 6,450 by 1,800 volt amps. Once again, applying the Ohm's law. And the answer there would give us a 3.5 for minimum number of general lighting circuits. That decimal of 0.5, we must round up to the next whole number. So our answer is we need a minimum of 4 general lighting circuits at 15 amps for this home. Now let's do this again. This time we'll use 20 amp general lighting circuits. So once again, we have 6,450 VA after we multiply our square footage times our 3 VA. Then we're going to divide that now by 2,400 volt amps. That's using the Ohm's law, applying the 20 amp circuits by the 120 volts. And our answer now is 2.6 minimum general lighting circuits. That 0.6 we need to round up once again, and our answer is a total of 3 general lighting circuits would be minimally required at 20 amps for this home. I hope you found this video helpful. If you like this video, please watch one of our other videos on practical or electrical theory. Don't forget to like and subscribe or drop us a comment. Thank you for your time.